Math 107, Final Exam Review, questions number 29, 30, and 31. Question number 29. Evaluate each of the following without using a calculator. Well, the best way to do this when an equation is written in logarithmic form is to change it into exponential form. Then it's just easier to have the answers pop out at you. So for letter A, we have 2 is the base. The base is always written smaller. Raised to the x, and that equals 16, which is always the higher or the taller number within the log. So what exponent on 2 creates 16? Well, 2 times 2 is 4, times 2 is 8, times a fourth 2 is 16. So the exponent of 4 creates 16. All right, letter B. What exponent on the base of 3 makes 1 over 9? Well, another way that we could write 1 over 9 is 1 over 3 squared. The only way to get a number to travel to the opposite side of the fraction bar is to make that exponent negative. So I know if 3 is raised to the negative 2, it will cross the fraction bar and become squared. So x, the exponent, is negative 2. Letter C. B to the x equals b to the third. Well, here's an important rule of exponents, which says if we have the same base, then the exponents have to be equal. So x has to be 3. Letter D, when there is no base written and it's log, we can say that the base is 10. 10 to the x equals 0.001. So how many places, we know it's 1 over, because it's a decimal, 1 over 10 to the 1, 2, 3. So the exponent of 10, 1 over 1,000, is the same as 1 or 0.0001. So in order to have an exponent cross the fraction bar, x had to be negative 3. Letter E. When there is no base written and it's natural log, then the base is e. So I want the exponent on e that will create the number within the log, which is e. Since they are the same base, then x has to be 1. Because that is the exponent on e. All right, letter F. This time again, the base is e. So e raised to the x equals 1. The only exponent on any non-zero item that will create 1 is 0. So an exponent of 0 creates 1. Number 30, write each of the following in exponential form. All right, remember the single isolated number is always the exponent. So I have the base of 3 and the exponent of 2, and that equals x. So x equals 3 squared, which is 9. You didn't have to solve it, but this is an easy one to solve. Letter B. This time, when there is no base mentioned and you have a log, then the base is 10. 10 raised to the x equals 100. That would be your exponential form. But I know that I can go ahead and solve it because the exponent on x that creates 100 on the base of 10 is 2. All right, number 31, 27, it says solve each exponential equation without using logarithms. All right, when I am not allowed to put it in logarithmic form, then an important rule to remember is that if I have the same base, if I can get the bases to be the same number, then the exponents are equal to each other. So I can come up with an equation. 27 is 3 raised to the third. So 3 raised to the third is 27. And 3 raised to the third is the number 27, which is being raised to the x. And that is the same as 1/9. Now 1/9 is 3 raised to the, we're back up here, 3 raised to the -2nd. Remember that when parentheses separate exponents, we can multiply them. So I actually have established a little equation here. When the bases are the same, both of these are base 3, I can set the exponents equal to each other, just like in the above rule over here. So 3 to the x equals -2, divide by 3, and x equals -2/3. I can do the same thing for letter B. 8 is the same as 2 raised to the third power. 2 raised to the third power. So this is the number 8, and it is being raised to the x minus 1. On the other side, 16 is the same as 2 being raised to the fourth power. When I have the same base, as I do here, the base is 2, on both sides of the equation, then I can set these exponents equal to each other. Let's distribute the inside the parentheses to get 3x minus 3 equals 4. I can add 3. 3x equals 7. Divide by 3, and x equals 7/3.